R.H. Yadav presents ISRO's Aditya L1 mission. Aditya L1 is the first space-based observatory-class Indian solar mission to study the Sun. The spacecraft is planned to be placed in a halo orbit around the Lagrangian point 1, L1, of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. A satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the Sun without any occultation, eclipse. This will provide a greater advantage of observing the solar activities continuously. The spacecraft will carry 7 payloads to observe the photosphere, chromosphere, and the outermost layers of the Sun. The corona, using electromagnetic and particle detectors. Using the special vantage point of L1, 4 payloads will directly view the Sun and the remaining 3 payloads will carry out in situ studies of particles and fields at the Lagrange point L1. The suite of Aditya L1 payloads are expected to provide most crucial information to understand the problems of coronal heating, coronal mass ejection, pre-flare and flare activities, and their characteristics, dynamics of space weather, study of the propagation of particles, fields in the interplanetary medium, etc. What are Lagrange points? For a two-body gravitational system, the Lagrange points are the positions in space where a small object tends to stay, if put there. These points in space for a two-body system such as Sun and Earth can be used by the spacecraft to remain at these positions with reduced fuel consumption. Technically, at Lagrange point, the gravitational pull of the two large bodies equals the necessary centripetal force required for a small object to move with them. For two-body gravitational systems, there are total 5 Lagrange points, denoted as L1, L2, L3, L4, and L5. The Lagrange point L1 lies between Sun-Earth line. The distance of L1 from Earth is approximately 1% of the Earth-Sun distance. Objectives of Aditya L1 mission. The major science objectives of Aditya L1 mission are: study of solar upper atmospheric, chromosphere and corona, dynamics. Study of chromospheric and coronal heating, physics of the partially ionized plasma, initiation of the coronal mass ejections, and flares. Observe the in situ particle and plasma environment providing data for the study of particle dynamics from the Sun. Physics of solar corona and its heating mechanism. Diagnostics of the coronal and coronal loops plasma, temperature, velocity and density. Development, dynamics and origin of CMEs. Identify the sequence of processes that occur at multiple layers, chromosphere, base and extended corona, which eventually leads to solar eruptive events. Magnetic field topology and magnetic field measurements in the solar corona. Drivers for space weather, origin, composition and dynamics of solar wind. Thanks for watching this video. Hit like, share and subscribe. Thanks for watching.